Welcome to this video on how we're going to be plotting some gorgeous scatter graphs. So some points about graphs. Graphs are all about spotting patterns and they're all about communicating that to the world. Every graph should be drawn with a sharp pencil. It's got to be big enough to actually spot the patterns, a sensible scale which makes the data easy to plot. Can't emphasize that enough. A graph, if you're finding graphs onerous to plot, it probably is because your scale is not sensible. And generally you want, because your grid squares on graph paper tend to be divided into grids of 10, you want something that goes into 10 nicely. So you want one big square to be maybe 10 or 1 or 2 or 5, but not 3 or 7. You're going to find yourself having a nightmare then. All the data have got to fit on. You can't have data dangling over the edge of the scale. The data should take up most of the space, and that means you don't have to start your axes on 0. You do have to make sure you label your axes, and units for scientific measurements are really important. Some graphs might have to have a title explaining what the graph actually is or what it shows. That's not essential. Sometimes the axis titles are sufficient. You need a key as well, which shows which data are which, particularly where this is really if you've got multiple sets of data you're plotting on the same grid. And if you're using secondary data, you need to identify your data sources. So let's make a start. Here are some data over here on the number of carbons in an alkane and the flash point. These are from the engineering toolbox. I've started at 3 carbons and gone up to 10. So first thing we need to try and do is decide which variable is which. So in this case the independent variable is going to be the number of carbons. That's going to be the one which we are changing. We're changing the number of carbons to see how the flash point changes. Now the independent variable always goes on the horizontal axis, which people typically know as the x-axis, and the dependent variable, in this case the flash point, is going to go on the y-axis. So we're going to try and now have a look at how we're going to get those axes drawn out. We need to understand how many squares do we need to draw on our grid in order to get this to work nicely. So we've got 18 squares of width, and I want to go actually all the way from 1 to 9 carbons, so I need 9 squares. I've got 18 squares. I could do 2 squares is 1 carbon and just fit it on, but to give me enough space I'm actually just going to go for 1 square is 1 carbon. Just makes life very, very easy to do that plotting. What about for the y-axis? It's a bit more complicated here. I've got 12 squares. I need to fit in a range from, if this is all going to fit on, this needs to be at least down to minus 110. This needs to be at least up to 50, rounding it to the nearest 10. That means I need 160 degrees C of range, but I've only got 12 squares, so I can't do 1 square is 10 degrees C. So I'm going to have to go for 1 square is 20 degrees C, and that's going to make plotting slightly harder, but it shouldn't be too difficult. And as a result of that, just to make sure that 0 is on a grid square, I'm going to actually plot this all the way from 60 down to minus 120, which gives me a range of 180. So I need a total of 9 squares. And that's similar for the horizontal axis. I need 9 squares for that one as well. So let's have a go at this. If I were you, I would have a ruler at this point, but I'm just going to draw up the lines from here, and I'm going to start there, and I need to go 9 squares up for my dependent variables. So that's starting there and going up 1, 2, 3, 4, 5, 6, 7, 8, 9, and there like that. And then I'm going to go across here from minus 120, 100, 80, 60, 40, 20. I'm going to go across here, and I'm going to go 9 again there, because I'm going to have 1 on the end, 3, 6 and 9, so it's going to end about there. Perfect. Right, I now want to just label up my axes. So in this case this is this here is the flash point in degrees C. And I'm just going to put my numbers on there. I start at 60, 40, 20, 0, and so on and so forth. On the horizontal axis, this is the number of carbons. I'm actually going to start there at 1 and I'm going to carry on going 3, etc. So onto plotting points. There are my axes all set up. That should be, apologies, that should be the flash point that's there rather than the boiling point. I think that's correct on the others, but it should be the flash point. Right, we now need to do some plotting of points, and there are basically 2 points that I'd recommend, the cross and the plus. They're both very, very precise in terms of exactly where you want to plot the point. I would go for the plus. Let me show you how you can use a plus in order to do this. So if I pick up a ruler, then I can go for the first point. I need to do 3 carbons, flash point -104. So I can go to here and find myself on -104, so that is 2 squares down, and I'm going to come across the point when I want 3 carbons, so it should be something like that. -104, and then I just rotate my ruler, get exactly where I want it, and again I stick it where 3 carbons is. And I can finish off my line there. This is ever so slightly off because of the resolution, but that's how you do it, and you just carry on plotting the points. If you want to use a cross, there's no trouble, you can use a cross if you like. The way you do a cross, say for 4 and 60, it's relatively easy here because these are all on the big grid squares. There's no guarantee that will be the case. We're going to do it there, so we're going to have just put in like that. A little bit quicker with the cross, 5 and -49, so that's going to come in around about there, and so on and so forth. So there they are, all plotted. Now it comes to the line of best fit. So this is a tricky one. The first thing I would try with the line of best fit is a straight line of best fit. So if I come here, I'm just going to rotate the ruler, try and get something that fits through all these points of the straight line. Unfortunately, when I do that, I come up with a bit of a problem here, is that this point here seems to be wildly off the line. And no matter how I do it, if I do it like that, then I end up with all these points a long way away from the line. There does seem to be that there could be a little bit of a curve to the data here. So if the straight line isn't working, you can go for a curved line of best fit. There's nothing wrong with that. If you do, I suggest you put your elbow right here, and then you get on the inside of the curve and just put your elbow on the paper and then just swing your arm round through these. I'll show you a few attempts at this, but it's very, very difficult to do on a computer, but something like that potentially would work. Try another one. Like that. That's not too bad. That's got a reasonable distribution of the points, some on the bottom side, some on the top side. Perhaps it could curve a little bit further down here. But actually in this case, I'm going to show you another option you've got, which is saying that actually if you look at these points here, they're actually pretty much dead on a straight line, aren't they? So we could draw a nice best fit line going through those points that would fit them pretty well. You've got a roughly even spread of them below and above the line, very small distance to the points. That looks pretty good. The only thing is this point would seem to be an outlier from those data. Now it might be that we just don't have a sophisticated enough model for this here, but what I'm going to do, if you do find yourself in this situation, and particularly if it's not the first point or the last point, but some point in the middle here that's well off a line, you can just circle that and say that point there, we think that's an anomaly. And you basically ignore it from the data set. So that's your line of best fit. Final thing is predicting points. So what would we say here is the flash point of an alkane with 6 carbons. How can we work out the flash point of an alkane with 6 carbons? And I do apologise, these all here should be flash point, not boiling point. Flash point of an alkane with 6 carbons. Now what people sometimes do here is they look for 6 carbons and they look down to the line and then they just put a little point on there. That is a no-no. We don't have any data at 6 carbons, so we shouldn't put a point on there. You are right though, if you're doing that, that you need to somehow read off what the flash point would be at this point on the best fit line, and that's the basic idea. And we use a construction line to help us, so we get a vertical ruler because we're starting with the known 6 carbons, and we just take our pen and we draw down. It could be a dashed line or it could be a solid line, it doesn't matter. We just draw down to the best fit line from 6. Then we need to draw a cross from there to find our boiling point. So, presuming that's about right, we're going to come there. It's slightly inaccurate, but it's about as good as we're going to do. We'd find out there that our flash point is around about, 3 full squares and a little bit. So that's going to be about 7. So it's going to be about minus 27 degrees C. I'm reading off this value here to get it. So just to summarise, scatter graphs. They are probably the most common graph in science. You use them to look for relationships and describe them, and particularly when you want to try and make predictions, either interpolating like we did there or extrapolating outside the range of the data. It's a bit more dangerous, but you can use a scatter graph. So whenever you see a question asking you to describe a relationship or make predictions, a scatter graph's the way to go. Your independent variable comes on the horizontal axis, your dependent variable on the vertical axis, and both of those have what we call continuous scales. So that means 10, in this case, 5 squares is 10 newtons. Another 5 squares, another 10 newtons. 5 squares, 1 centimetre. 5 squares, 1 centimetre added on. You plot your points as crosses or pluses. I really like pluses. A best fit line should not join the points. It should go with roughly equal numbers on either side, trying to minimise the distance between the points and the line. And if you think, as in this case, this point here is just well off, you can give it a circle and ignore it, so you don't curve your best fit line to go through it. And finally, the dash blue lines here, if you want to try and imagine what the points would be, then you need to use a construction line to make predictions.